Hey, welcome everybody. This is actually this is sort of the last video where we're covering new content. So I just want to say congratulations on making it this far. And I know it's been kind of weird working from home and all that stuff. So that's it. This should be our last new content video, and this is about expected values. And let's get right to work here. So this is 9.5, and the last topic of the year for us is expected values. And what it means is this. It's nice to think of a game you'd play, like if you paid money to play it, and you'd win some money or you could lose some money. And these are your payoffs, right? So the expected value of a game really works like this. The probability that this occurs, that event occurs, multiplied by its probability, and just sum them up, right? If you think of a casino in Vegas, and if you're going to play roulette, which I don't know anything about gambling really, but if you're going to play roulette, and I don't know what it costs to play a game of roulette, maybe it's $5 or $100, I don't know, then thered be a probability that you would win or you would lose. So if you and that would be these X values, would be the value of the game. Like if you're paying, that's a negative towards you. If you're winning, it's a positive towards you. Then you got the probability that the events occur. You have to calculate those. All right, so what they call is fair is if the expected value of a game is 0, then the game is called fair. Well, I don't think anybody in Vegas is playing fair games or they wouldn't be in business, right? So it's always going to be negative with respect to you if you're playing games in Vegas. But they're not too negative because then nobody would ever play them. So these guys play them over the long haul. A lot of different, a lot of people play. Then even if you're gaining a little bit on average per person, in the bigger picture, they come out to the good. All right, so here's my fair game example. It's a very simple one. I think it's a good one. A football game has a coin toss, right? And that tells who takes the field and what order they do so. So it says, imagine a game where a coin's tossed. If the outcome is heads, you gain a point. If the outcome's tails, you lose a point. All right, does this sound fair? Well, according to this theorem, let's see how it would work out. All right, we're talking coin tosses here, and that's usually pretty straightforward. And we said if the probability of a head, right, which we know happens to be 1/2, and they told me that we gain a point, right? And the probability of a tail is also 1/2, and we lose a point. Okay, so to calculate this expected value, we'll call that E of X, right? Then we would say, all right, the probability or the value of a head is 1 times the probability that it happens, plus the value of a tail times the probability that it happens. And I think it's pretty clear. Oops, that's a little messy. Then we get 1/2 minus 1/2, which is 0. So that is a fair game, the simplest fair game you could probably come up with. And we're in position here to do the next example, I think. So we can just make this a one video deal. So anyway, example 2. So this one right here is a little more complicated. So this one says, consider a game in which a fair die is rolled. And you win points or lose points as follows. So we're going to say if this game is going to favor us or not. All right, so we're playing this game. If we get a positive outcome, it's in our favor. A negative outcome is not. If it's a 0, then it's considered a fair game. All right, so let's get to work here. And just write this stuff down and follow me to this tablet here. All right, so always comes out with that bomb first. All right, we want to know what's the probability. The first thing we have to do is calculate some probabilities of a 1, 2, or 3. Well, there's 3 favorable outcomes with a total of 6 outcomes, so that's 3, 6, right? And what's the probability of a 4 or 5? Well, there's 2 outcomes. They're favorable. 6 total outcomes again. And finally, we want to know what the probability of a 6 is. And it's 1 favorable outcome with 6 total. All right. Now we're ready to calculate our expected value. Okay, so we win 10 points if it's 1, 2, or 3. We lose 13 if it's 4 or 5, right? And finally, we lose 1 point if it's a 6. And we calculate this thing up to be 0.5. So this game favors us. And we would win on average half a point if played many, many times. All right. Anyway, that's how the expected values work. There's an Excel that I put in for you to do. If it gets out of control and crazy, let me know. Anyway, I hope this is helpful for you. This is how expected values are calculated. The only thing that might get you is sometimes the probabilities can be kind of tricky to find, and then that makes this harder. The concept itself is I think, very straightforward and simple, but depending on how hard the probabilities are to compute, it can be tricky because once you can't count something, it makes it a little harder. So let me know how it goes in the IXL, and I hope this was helpful for you.